Gentlemen, welcome.
Hello.
Hey.
Let me get you the meeting minutes. And we'll start rolling here in a moment. Bob, your last, I just think of tables, man. I can't think of the, starts with the K.
Yep, killing. It's all good.
Killing in the name of.
Nice.
Now it's like when I was growing up, we had to write our last name first and first name last. So it was always like Killing Bob. And the other funny thing is my father's a doctor. So Dr. Killen. And he actually used to work with a Dr. Slaughter. So can you imagine being paged like Dr. Killen and Dr. Slaughter?
You can't spell slaughter without laughter.
Nice. Yeah. Oh, let me see if we can get. Bear with me one moment. Let me see if I need to switch accounts here. Let's see.
Oh, memory.
Okay, very good. I think we've got recording up now, don't we?
It's set to automatic, so it popped on like right when I logged in.
Did it? Okay, nice. Well, good. Well, hey, gents, nice to have you guys on. Let's get rolling. So it's the CNCF Tag Network meeting for Thursday, July 21st, 2022. We've got a couple of topics in the agenda today. I anticipate we'll probably go about half of today's length. Usually we have, so I think most of you have been on this particular call before, but just as the briefest of reminders, we end up using the time to do both tag network topics and service mesh working group topics. The service mesh working group, the vast majority of folks that are involved there are scheduling for next time around. And so very light set of agenda there today. Really just a note that the Cilium service mesh would GA'd yesterday. And there's some action items and a scheduled demonstration of mesh map for next we meet, which leaves us with the single topic for Tag Network today, which is the Istio's incubation proposal. And so Craig is here helping represent the project. Mitch is here helping represent the project. And Bob, I assume that's the same statement is true for you as well.
Bob is here to keep us honest.
Okay. Nice, good. And so, gents, if I could maybe hand the mic over to you and let you talk to us about Istio and getting it into incubation.
All right, I'm going to do a complicated dance with Zoom and see what happens. You cannot start screen share while, so first of all, Lee, I might need to ask you to stop. Thank you. I hope I can share just a Chrome.
Looks good.
Nice.
Craig, you're muted.
All right, sorry, it was sharing audio, which it did not need to do. So you can hear me now. You can see the screen. All going well. You will see it advanced slides. All right, good time of watching the recording, everybody. I'm Craig. I'm on the steering committee for the Istio project, and I'm helping guide its path into the Cloud Native Computing Foundation. So today we're going to do a little presentation, a few things that particularly Lee's asked to see, general overview of the project. We're going to talk about what it does and what it's going to do, and take any questions in particular. And if anyone watching the recording has any follow-up questions, the Istio CNCF or Kubernetes Slacks are good places to get hold of all of us. Lee will no doubt have the Tag Network Slack link in the notes, which you find afterwards. All right. For the benefit of the service mesh working group, I'm not going to go too deeply into defining what a service mesh is, but to say that we define Istio as transparently providing a uniform and efficient way to secure, connect, and monitor services in cloud-native applications. That is to say, it's largely defined the space as the first sidecar-based service mesh, the first one to use Envoy. We'll talk a little bit about the context in a moment. Key features that we see, the three primary things, as you saw on the last slide, security and especially zero trust networking is a big driver for people wanting to adopt Istio at the moment. Being able to apply mutual TLS encryption with identities for the services. It handles traffic routing and management, load balancing across many different protocols. Allows you to have fine-grained control of traffic behavior routing, failovers, and so on. We have a policy API supporting access control, role-based access control, again, based on identities, rate limiting quotas. And we have a bunch of observability features generating metrics, logs, and traces for all traffic within a cluster. And then an extensible data plane, which we'll talk a little bit about as we go through as well. Generally, the way that we describe Istio to people is it runs a microservices proxy alongside every workload. It's important that the proxy runs alongside the workload because that ties the identity of the proxy to the identity of the workload, which means you can do things like mutual TLS encryption using those identities, and also provides a method for accounting for the CPU and memory usage of the proxy along with the workload versus previous approaches where you have just a single proxy running on a node, for example. So you move from a world where you have just your service operating to a system that injects the sidecars, so it runs a container in the same namespace and such as your workload itself. And the Istio control plane handles coordination with the Kubernetes environment to learn about what services are available. It handles passing configuration information to the proxies, whether it be Envoy or also have some support for operating gRPC in proxyless mode, and all using the XDS Universal Data Plane API, and then also runs as a certificate authority, which you can chain to upstream authorities if you wish to generate certificates and dispense them to each workload based on their identities. And then the blue line is also refers back to metrics. So the metrics that are generated by the proxies, they are generally sent to a Prometheus instance or something that runs as part of the operation of Istio, but not to the Istio binary itself. Here's a timeline of where Istio fits in the history of what we now call service mesh. Work was started in 2016, and the first public version of Istio was released in early 2017. The inception of the project was conversations between people at Google who had built Kubernetes with people who had built the sidecar-based internal API serving infrastructure that Google operates, and our people who were building cloud API gateway products. Like we'd gone on with Kubernetes, there was a desire for an open platform for this purpose. So the team looked at what was on the market at the time. Linkerd was a few months old. That was the version 1, which was designed to run on the JVM and run per node. So it was too resource heavy to operate in the sidecar model. Envoy had recently been open sourced. So we worked with the team there on the enhancements that were necessary to make it API controllable and have all the features we needed to operate, just some small changes there to make it fit the need. There's also, we mentioned there, Amalgamate, which is a project which was doing a sort of a proto-service mesh based on Nginx that came out of IBM. And when we discovered that project, we had conversations with them about what it was that we wanted to build. I say we here as Google. Google had conversations with them about what happened, and then they decided to join forces with Google and team up to found the Istio project. Lee had asked us to talk about where Istio fits in the fact that there are some other service meshes in the CNCF at the moment. So I shall talk to those in particular. We have gone through and looked at the last 12 months of participation measured by the CNCF DevStats. These numbers will not look the same if you go and generate them today, because it's a rolling last 12 months. Unfortunately, there's no easy way to do between two different dates, but they will presumably be quite similar. So things that we think are important here are merged PRs. So these are obviously PRs sent in by someone that were actually merged in the community. And then also the number of individuals whom that represents. It's very obvious that a lot of these projects are built by people who are paid to work on them by particular vendors. So we look a lot at that, as you'll see, as we look at the vendors who make up the Istio project. But we've looked at, in the context of some of these service meshes here, the number of different companies that have a person contributing, more than one person contributing. And then out of interest, I also looked at the number of companies that have more than one contributor working on a particular project. So there are an awful lot of projects that are primarily led by a single vendor and have the occasional drive-by PR from somebody else. Istio is truly a multi-vendor project. We have large number of people who are building projects on, which I'll talk to momentarily, and a large amount of support from a very large set of the Kubernetes industry. There are another couple of projects in the space also that are not CNCF projects that we can't do dev stats for, and realistically the best thing we can do there is look at vanity metrics on GitHub. But similarly, we look here and say Istio is sort of minimum 3x in terms of stars and watches and so on for the main set of service mesh products we're looking at here. Console is obviously an outlier because it's not just a service mesh, it's actually a service directory that has a mesh component. So its numbers are more comparable, but it does a lot of different things, and its mesh functionality is just a part of what it does. We note, according to your agenda today, also that Cilium's service mesh functionality has just gone GA. Cilium's mesh functionality actually supports control planes on top. Istio is one of those control planes, and they exist as a data path that can, that can be plugged in underneath the main Istio control plane. I mentioned the number of vendors here. So the logos on this slide are all companies that either have an Istio-powered service mesh product or offer Istio as an add-on to their hosted or managed Kubernetes project. They are largely in order of number of contributions in the first couple of rows, and then sort of in order that they were added after that. So there are Google, IBM, Red Hat, obviously mentioned they're the early contributors to the project. We have VMware, Cisco, who have Kubernetes products and have hosted service mesh versions available. Cisco have just done a big thing. Callisti, I think, is the name of their new product there. There's also a number of companies that were founded to commercialize and work with Istio. Tetrade, especially, founded by some of the Istio product managers and engineers in the early team at Google. Solo, who have basically pivoted their business from generic API gateway and Envoy stuff more towards Istio. Aspen Mesh is a sub-project of the F5 networking focused on Istio. And then a number of large vendors, obviously Intel do network cards and they want to accelerate performance of traffic through there. There are a number of people who have serverless platforms who have integrations. They use Istio there. We integrate with projects like Knative, for example, to be the traffic routing layer. There are a lot of other integrations that you can learn about on our website. So the context of the conversation today is why Istio is applying to join the CNCF. So a few reasons here. So I mentioned Knative there before. Kubernetes, obviously, Istio was developed to be complementary and developed between those two things. So Kubernetes obviously developed first at Google, then Istio, and then Knative after that. It's a stack that lays neatly on top of one another. The fact of the matter is that we are joining as a mature project. We've hit 5 years old recently. And a thing that we find with Istio and have found for many years is that it provides features that are relevant to people who are not even necessarily using Kubernetes or other cloud native technologies. We've heard people, we've got AutoTrader, who are a great case study. They wanted to get security encryption of all traffic on the network And they weren't using Kubernetes at the time, but because they saw that Istio was the thing that was able to do that, they were able to take their applications, put them in containers such that they could run on Kubernetes, so that they could use Istio to drive the goal, which was actually required by one of their manufacturing partners who said, we've got a GDPR requirement that everything be encrypted. So we know that there are people who are adopting the service mesh as a platform that's actually pulling through other cloud native application. We're also looking at how we can accelerate the feedback and feature and development cycle, not just of Istio, but the partner projects, and how we can drive more community innovation. We'll talk about a couple of specific examples, but Kubernetes is built upon and depends upon a lot of CNCF projects. Kubernetes, obviously, Envoy, the data plane, as mentioned, is a graduated project in the CNCF. A lot of support and use for gRPC, uses specific identities, and there are a lot of different CNCF projects that have integrations that integrate with Istio. And as we're looking now to further innovate in the community and the things like the Gateway API for Service Mesh that are in the Kubernetes project, bringing them together and bringing them all under the same roof feels like the right time to do that. A couple of examples. Example of one thing that the Istio team has been doing to lead development within the CNCF project. We built in support for a WebAssembly runtime into the Envoy proxy. We built an ABI specification for running WebAssembly engines inside proxies so that you can build a module, compile it into run inside an HTTP proxy server, and that you would be able to then take that module and apply that to any other proxy server that picked up the same ABI. That's also an example of our responsiveness to user feedback. We did this because we actually had an extensibility model in the past where you would always make a call out to an external control plane component when you wanted to do checks, when you wanted to do authentication or anything. And although that was cached, that was deemed to be too slow and too heavyweight for most end users. It was a model that worked well at Google scale, but it didn't work for everybody. And so by building out extensibility into the proxy server, we're able to push that down and speed up the performance for most use cases. Another example of how we're working with CNCF projects is we're currently driving evolution in the Kubernetes Gateway API. It was very much influenced by the Istio APIs. And we're also very excited that the SMI community has recently got on board with this project. We're collectively looking to drive the Gateway API as the standard set of APIs for service mesh implementations. We're looking for it to be the default API for traffic management in Istio when it is ready. And in terms of interoperability with other implementations, I mean, we use standard protocols such as Spiffy, which allows us to interoperate with other endpoints and Envoy-based mesh implementations. Let's talk a little bit about the project itself. CNCF and industry surveys show that Istio is the most commonly used service mesh in production. The logos on the slide are people who have either submitted a written case study for our website or given a video presentation at one of our IstioCon events talking about their production use of Istio. There are about 100 more logos on the users page of people that we know are running Istio in production and have listed themselves there as users. Here are some of the numbers from the dev stats. I just have a little note there to say that these are not exactly the same numbers as the ones you saw earlier because they were generated over a different 12-month window, but these are the ones from the due diligence document. And they say that overall we've had almost 9,000 people who've made a contribution to Istio over its life cycle, with almost 2,000 people having done so in the last 12 months. About 1,500 people have had a pull request merged into Istio. Again, 300-ish in the last 12 months. And the same there is true of companies. So there's over 190 companies that have contributed in some way to Istio, with 67 companies contributing in the last 12 months. Talk a little bit about the governance model. We have two different committees that make up the governance for the Istio project. Steering committee is responsible for the administration, the care and feeding of press and media and blogs and all those kind of things. All of the running of the technical aspects of the project is delegated through to the technical oversight committee and the working groups, which you'll see on the next page. We have two different models for how we maintain them. As we've mentioned before, all of the work to any first level approximation done on projects like this are done by people paid to do so by a company. So the seats on steering committee are allocated in proportion to company contribution to the project. There are 9 of 13 seats that are allocated that way. And the formula we use is voted on every year, but effectively it's set up such that overall no one vendor can have more than 50% control on the board. and that there will always be at least 3 companies that are represented in that way. So at the moment, we have representatives from Google, IBM, Red Hat, and Dow Cloud, who are represented by their contribution to Istio through the number of merge pull requests. We know that that's not a perfect representation, but that's as fair as any that we've found in the past. And because we know that's not a perfectly fair representation, we also have 4 seats that are elected by community vote. Those 4 seats must go to people who are employed by different companies, and they are not applicable for people who have a seat through their contribution. So that means that at any point we are guaranteed to have representation from at least 7 different organizations on the steering committee for the project. The Technical Oversight Committee, responsible for code and working groups and so on, they are seats that belong to individuals. And in fact, there are at least 2 people on the group who have taken their seat between companies as they moved between them in the past. The goal of that group is to have an even number of members, such as to drive technical consensus. It almost never has to vote on anything. The representatives at the moment, we have 5. We're currently in the process of appointing a 6th. So we have Louis and Lynn, who are 2 of the very early founders, engineers on the project. And then we also have Eric from IBM, John from Google, and Niraj, who's currently at Solo.
Craig, question on the 9 seats for company contribution.
Yes.
Are those, those are, yep, those are just as measured, yeah. Yeah, those are as measured from like the stats that you were showing before. And that's an automatic assignment to the top 9.
Yes, so we have used the same formula for the 3 odd years that we've done this. And we basically run what they call a Jefferson election, or the DeHont method, which says based on your number of merge pull requests, the highest person gets allocated the first seat, and then that number is cut in half. And so we run the second round again and say whether or not the person who was second place in terms of contribution may well now be in top, because the first person, it decays over time. That's all published in the Istio community repository. I can show you an example of that afterwards if you're interested. But we also stop at any point where if there's some person gets to 5 seats out of those 9, then they're ineligible for further seats. So of the 9 at the moment, then I would say 5 of them are allocated to Google through their contribution to Istio, 3 of them are allocated to IBM and Red Hat, and the final one is allocated to Dow Cloud.
Got you. Okay,
yeah.
That makes sense.
So the goal here is that representation, and this is a way of ensuring that the project is maintained by the people who actually are doing the work on it, that they're seeing it through. All right, so we have, I think it's 8, if my counting on this tiny screen is correct, 8 working groups who represent various different parts of the project. Something I didn't mention before is that eligibility to be on the Technical Oversight Committee is by way of having been a working group lead at some point. So membership to the project, someone who has had at least 1 PR successfully merged can apply to become a member, which basically means that they don't need to ask someone else who's a member to have the tests run on their subsequent PRs. And we encourage people to get involved with a working group that matches which part of the project they're interested in. Over time, the leads and the TOC will choose to elevate them and have someone become a leader of one of those working groups. Mitch is on the call right now. He's the leader of the user experience working group, for example. And then someone who is the pool of candidates who are applicable to choose from for open TOC seats are the people who are or have previously been a leader of a working group.
Makes sense.
We talk about the performance. There's been a lot of FUD in the space in the past about what it actually means to run a service mesh. You are obviously running a container alongside every container that you run in your cluster, and you're running control planes as well. On the whole, we're trying to provide the benefits that you get with minimal resource overhead. And we measure this with every release. We make sure we don't cause any major regressions. Overall, we say that proxy you should expect to be a minimal sort of 40 megabytes and memory and 2.5 millisecond latency overhead for P99 in a typical cluster. There are obviously ways that you can find to change those benchmarks around to have atypical clusters, and we're constantly working on how we can improve things overall. But Istio as a whole scales to millions of requests per second to support clusters with hundreds of thousands of pods. And this data is all published on our website at every release. We have graphs that talk about the implications of having various features enabled and so on. On the whole, what we see from customers is that while obviously there is some cost to just the fact that you are now running more things inside your cluster, the benefits that you get outweigh that cost substantially, and the adoption we've seen is enough to say that people are definitely willing to pay that burden. One of the things we talk about in the design doc is responsiveness to user feedback. A few things I want to call out that the project's done in the 5 years it's been around. We launched with a control plane that was in the vein of the kind of services that we thought people would run on top of Istio. That was a microservices application. We obviously wanted to dog food our own service and have it be able to be managed by Istio as well. But it turned out that the assumptions that we made around why that would be were largely based on how we would operate the service at scale, and they were not necessarily applicable to how end users would operate that. So we've actually, we've done two things here. So the first thing we did was we consolidated all the components back down into a single binary, which made it a lot easier to manage. You don't have to worry about the upgrading of those components in order. You don't have to worry about scaling them independently. You almost never did need to do that. And the second thing that we did with help from a computer science professor in Brazil is we published a paper in the IEEE journal about that journey, which is linked. And I encourage anyone who's interested to read about that. We talked about the extensibility that we built into the proxy server before. We've done a lot of work on making Istio easy to use on the sort of day one side of things. We have built out a installer system, Istio-CTL. It lets you do verification, lets you analyze your configurations, check everything's okay, handles installation based on YAML configuration files. You can also use those same config files to run an operator if you wish. In general, we don't recommend people do that because we think it's a security product and you should be actually analyzing it yourself rather than trusting something. But that is a popular method for some people to do installations. And we've also recently revitalized our support for Helm. That's a thing that, again, based on user demand, we had some Helm 2 charts that have been upgraded to Helm 3, and they is another thing that we found that we couldn't get the performance we wanted in the most case, so we did build out installation logic in Istio-CTL, but there are still some people who install everything in their clusters with Helm, and we know it's important to meet users where they are. And last thing on this list, Mitch is welcome to answer any questions on when it comes to the end, because it's something that he's very much been driving, but it's extended support windows. We were previously supporting each release for about 6 months, but just under. And so someone would have to effectively update twice per year. And actually, I'm not sure I'm butchering this, Mitch. Was it 6 months or 3 months?
We supported for 6 months, but we release every 4. So if you're upgrading within the support window, you could only upgrade one version at a time, 1.3 to 1.4, 1.4 to 1.5, which effectively meant a quarterly cadence. So by adding an extra 6 weeks of support and supporting upgrades that skip a version, you can now pick like odds or evens and upgrade only twice a year.
Yeah, and that's another thing that's driven by a desire to keep customers more secure. We know that there are bugs in old versions of software, and that the best thing we can do is have people actually update. And if they know that they can do that safely, and that they can, previously, for example, you needed to upgrade 1.9, 1.10, 1.11, we now support skip version upgrades. You can upgrade 2 versions at once. And we are even seeing people who are successfully upgrading things that we don't test, 1.7 straight to 1.11, for example. We'd like people to upgrade more frequently than that, and so we're making it very non-disruptive to do upgrades. All right, as we come to the end, we'll talk a little bit about what we're doing this year and the roadmap we're currently executing on. 5 major things here. The Istio API service. We have a lot of APIs that are still V1 beta something, and we're looking at what we need to do to move those to V1. We have a bunch of configuration things that are in a big blob of YAML that we're moving out to APIs that are more specific to their use cases, data plane APIs, a new telemetry API for controlling how telemetry works. We talked a bit about upgrading and Helm, for example, and revision-based label upgrades. So we have ways of getting people to canary test and say this is a new version rolled out to a certain set of clusters, and then by labeling that version, say, all right, it's now safe to roll that out in a way that it's easier to have more stable upgrades. We're talking about enhancement of extensibility through APIs to deploy those WebAssembly plugins that we mentioned before, through building out custom authorization support, integrations for things like your own certificate authority, making that easier to configure. Expanding the reach of what we can do with Istio by supporting things like IPv6 and dual stack clusters, by supporting builds on the ARM architecture, and configuring proxyless workloads that are running gRPC. gRPC has support for the Envoy XDS APIs, so you're able to configure the traffic routing and not have to run a proxy alongside certain gRPC workloads. And then further security hardening. As a security firewalling product, we're always on the top of this. We publish a lot of CVEs because we're paying attention and we're constantly vigilant in this case. We're looking to publish more software bill of materials resources, do more fuzz testing, and help people run in secure configurations by default. Obviously, this is something you can configure as you want. You can turn on or off a lot of the security features, and we want it to be that Istio works with those security features out of the box, and so people aren't discouraged from using them, and that we are able to turn them on by default. That is largely the roadmap of work that we're executing on this year. Everything's progressing very well there. And that brings me to the end of my presentation. So thank you very much.
This is great, Craig. This is great.
Thank you.
Some questions. Just on the last slide, you were talking about extensibility and expanding that. One of those examples being kind of the proxyless with gRPC, and curious about focus toward eBPF as an already supported, technology, an alternative data plane to use. Is there more to be done there?
So Istio, we have some proof of concepts that have been published in cooperation with Thomas Graf and Cilium that show using eBPF in lieu of IP tables in order to allow the proxy to capture traffic within the scope of a pod. There's some performance gain to be had there. But by and large, that's at the level of proof of concept. There are a few users that are sort of using it as a curiosity. It's not, as far as we've seen, it's not something that our users care about enough to bring into the mainstream or to make a required part of the product today. That being said, a new proof of concept for Istio and eBPF rolls off the assembly line like every 3 to 6 months. So it's something that we keep our eye on, but it's not risen to the level of roadmap yet.
Gotcha.
There's if the screen share is still working, there are a bunch of people, I link here a blog post from DAOcloud, built basically a plugin where you allocate a daemon set that will do what Mitch said. It will use eBPF to route traffic into the envoys rather than using IP tables. They talk a little bit, I think at the bottom of this, there's a graph where it says it's moderately quicker. It cuts a few steps out of the data path rather than having to traverse the TCP/IP stack too many times. We can save a few steps, and on the whole, we get a small performance increase. Like that is the sort of thing. Like the reality is, as we mentioned before with eBPF, is it is a plumbing technology, and it cannot and possibly never will be able to do all the things that something like Envoy can do. And whether or not you would want it to, and how we would handle the cost allocations I mentioned before. If it's possible to put all that in the kernel, then like a user that is causing there to be more proxies run in a multi-tenant environment will probably need to have some way of allocating that back. And so there's discussion in the community about what that would look like, whether each listener thread and Envoy could be put in a C group that's measurable back to an end user. But on the whole, what we're seeing in the market is this desire to keep these things simple. And so eBPF can be used to help accelerate that, but we don't currently have any visibility into it being able to do more.
And Craig, this is actually worth calling out as something that I really love about the Istio project. Murbridge is part of the Istio ecosystem organization on GitHub. Basically, if we have contributors or users, a handful of them that are interested in doing something different with Istio, and they're willing to maintain it, we have a place for them to host their project. Admiral is one of the larger projects that's come out of, I think,
Intuit.
Thank you. I was going to call them Intel, but that's not right. Intuit. That's hosted in the Istio ecosystem section. So these are things that are not necessarily going to be of interest to all Istio users, but they're of interest to more than one. So we have these places to host these things, and occasionally something in the Istio ecosystem becomes popular enough that it does rise to the level of being actually imported into the project itself, if the maintainers of that project in Istio see eye to eye on that. So it's a really cool way of allowing experimentation and new ways of thinking about the project.
You mentioned Intel there. I'll just point out that they have a similar thing in that they have built out an engine for using eBPF to accelerate. And then they're obviously looking at how they can hardware accelerate that on their own network hardware as well. So there is a lot of parallel evolution in the community, but as of yet, it has not risen to the point where it's part of the product.
The Istio ecosystem org also helps kind of reinforce the characterization of Istio's or the size and the scope of the project, the amount of adoption, the amount of interest and participation.
I will call out for the record that Istio ecosystem is not one of the repositories that we transferred to the CNCF as part of this, because it contains a lot of a lot of old code, a lot of third-party code. We're not going to do the audit for that. So it will presumably exist in the same way that the Kubernetes SIGs repository exists versus Kubernetes. Like, there is a separate organization that is for interesting projects that people are working on that are contributed, but the ownership of that remains with the people who build them until such time as it graduates to being part of the project proper.
Nice. Thanks. That was my next question, which is, just to kind of reinforce that, which is to say that, or rather, let me ask this: have any of the projects that have previously been a part of the Istio ecosystem org, have they, in the last month or two, as part of this donation, have they graduated from ecosystem to core project?
That will happen. Yeah, sorry. So just, I'm not sure whether the video will reflect the chat, but Bob is pointing out that when I said Kubernetes SIGs, I meant Kubernetes Incubator. Thank you. There are about 3 classes of things that are currently in the ecosystem organization. There are active subprojects, Admiral being a major one that Mitch mentioned before. There are things that are example code for Istio that just needed their own repo. And then there is a bunch of stuff that's very old. And so we're going to go through an exercise upon acceptance to figure out what is in there. Admiral is a big enough project that it will exist in its own scope, and we're working with them on moving that out to being effectively a top-level project of its own. And then some of the examples will meet the requirements, and we'll go through and audit them. And some of the older projects, we're just going to archive them.
Got you. Speaking of other projects, you'd mentioned Gamma and SMI earlier. There's another spec project, SMP, Service Mesh Performance. And Mitch is familiar with this one. Any plans for participation there?
Lee, I don't know of any concrete plans, but I do know that I connected you with someone during KubeCon EU. Did that turn into something?
It didn't, but okay. But thank you for that.
Yeah. Overall on that topic, I'll reinforce what I said before, is that we publish our performance numbers. We target them to be as good or better and trending downwards. Obviously, there is a business value to be had for this. So I don't necessarily believe that the service mesh that has the lowest raw numbers in the speeds and feed sense is the one that you should be adopting. We encourage people to evaluate from a third-party perspective to evaluate. We have seen obviously in the past that there are a number of people who do this in a competitive sense and are able to target particular workloads that are unrealistic, that don't take real user patterns into account. The threading model of Envoy, for example, if you manage to say, I'm doing 1,000 requests per second, but you dump 1,000 requests at the 0 millisecond mark of every second, you get really poor performance, but no one does that in the real world. So when we actually see real world performance, it's in line with the benchmark numbers that we have, and we've worked a lot. We have a project called Fortio, which is a load testing tool that was built inside of Istio initially, and again, so it graduated out to be its own thing, working with the Envoy community on the Nighthawk tool and so on. So we encourage people to benchmark where appropriate, and we'll definitely make ourselves available if people from other projects are interested in benchmarking in any fashion. As Mitch says, we're more than happy to help guide them.
Yeah, I completely agree with that sentiment about misguided a misguided value comprehension of what a service mesh provides based on just speeds and feeds. It was just not the good. And yeah, to the extent that is helpful.
Dropping packets is faster than routing them. Let's just say that.
Yeah. The question, there's other ecosystem projects. One of the, so S&P is one of the ones that I help maintain. And another one is Meshery. And so I call out that I help maintain them only just to be on record about it, that there's a portion of Meshery that there's a Meshery adapter for Istio. There's a portion of Meshery that's coming out soon. It's a catalog of what will hopefully be sort of curated best practice deployment models. Some of what will be in the catalog would be WebAssembly filters, potentially eBPF programs, potentially OPA policies, things that are again kind of an open catalog for all to contribute to, but also to help elevate and help people be successful in adopting Istio and other service meshes. It's something to be aware of, just on the topic of integration.
Yeah, we publish a lot in terms of our deployment models and recommendations on the Istio website. I will note that there are third parties who have written books on how to best enjoy and configure Istio, and we very much love to see community participation in those areas.
That was actually a really common question at IstioCon this year. There were a number of presentations that covered OPA and gateway usage. And at most of those presentations, the top voted question was, is there a public repository of like, just go and pull off all the best practices in OPA and apply them to my cluster automatically? I don't think that that's necessarily a role of the Istio project to do. We considered it, but I do think that there are experts out there, similar to the Meshery project that might be able to move and be helpful to the community as a whole by publishing those best practices in something other than a TED Talk form.
Yeah, nice.
Hard to scrape YAML from video.
Yeah, that's great. That's great. So some of the, so you kind of spoke to, in part to why now. So Istio's, right around 5 years old, had considered benefits to participating directly within the CNCF previously, benefits to the CNCF, benefits to Istio. And I think you probably sufficiently covered it. It's always a difficult question to ask because a lot of that is sort of inherently obvious. And so one other item with respect to the notion that you've seen Istio as a project has seen helped, the example that you used was AutoTrader, like has helped organizations kind of pull forward toward Kubernetes, or has been a driving factor toward modernization from monolith to microservice. With respect to VM-based support and sort of Istio's tentacles or support for non-containerized services, is that—
I'm going to update the docs to use the word tentacles.
Yeah. Is that I don't know that you get that the project necessarily considers that falls into extensibility, but I wanted to ask that question in terms of roadmap, or in terms of is there more to do there, or is that not necessarily an area of active focus?
Yeah, I'll start on that, and then Mitch, I'd love to have you in as well. We've done a lot of work. I didn't explicitly call it out here. It may or may not be in the due diligence doc specifically, but you can run Istio in non-Kubernetes environments. By far and away, Kubernetes is the place where people run it most. And since the example that I gave you, we now have support for managing proxies that run on VMs alongside workloads. We've heard of people connected up in front of mainframes, for example. So there is benefit in being able to have a mesh which consists of all of the things that you need to operate for a large number of people who are undergoing a migration that will involve a lot of legacy stuff. being able to connect everything up with a mesh initially is great because you get all those benefits. And then as you move the workload from its VM or mainframe home to a container-based environment, you're still, nothing needs to change from the perspective of the services that are calling them. So it's a great way of modernizing things, picking them off one at a time as you make that migration. I can look up the exact support state. I know that it's stable or thereabouts in Istio at the moment, I'd say. So.
Yeah, I believe our VM support is listed as beta today, which until very recently, beta was as good as it got in Istio. We've been very hesitant to use the GA label for any of our APIs, just because we want to have a very long deprecation cycle. We want to consider ourselves committed for multiple years to a feature in an API before we call it GA. But yeah, I believe it's listed as beta. There's a few APIs out there that help us support it, like adding service endpoints for a VM, which of course doesn't show up in the endpoints list in Kubernetes. It's been out there for quite a while. The pain point is still, and I think it probably always will be, around orchestration. To run a service mesh, you need a proxy to capture all traffic everywhere. And Kubernetes provides this amazing hook called the mutating webhook for us to be able to do that internal to Kubernetes. As soon as you leave that orchestration program, the user is responsible for ensuring that traffic is captured across all of their mainframes, across all of their VMs. They might need to white box their proxy versus the normal black boxing paradigm. So orchestration is still painful, but I don't see that resolving in a super global way particularly soon, because there's not one orchestration layer for all of the things outside of Kubernetes that users might want to integrate. So for that reason, I think you'll see, I would not expect to see many VM native meshes running on Istio, where there's no Kubernetes involved, it's only VMs. There's going to be a lot of friction to a workflow like that. You're going to see more like, I have a microservices cluster with a lot of traffic on it, and there's also a few legacy VMs I need to bolt on. Maybe eventually I'll migrate them into the cluster. Istio excels at that.
Good. This is great. The presentation saved a number of questions, actually. Some of those around governance, some of those around community. Perhaps one or two more around. Well, some of what was shown helped answer or characterize differentiation for Istio as a project that is a service mesh, and as it relates to other, well, both CNCF and non-CNCF service mesh projects. I guess that the question that I'll ask is, have there been thoughts toward interoperability, sort of outside of interoperability with other service meshes, or those running in either similar or disparate environments? I'm gonna include like 5 questions where sort of common identity, the ability to interoperate between meshes in that way. And I guess like outside of Gamma, or outside of
Yeah, so the Gamma initiative, to be clear, is about being able to take configuration that applies to one environment and use that same configuration when you have a different engine. It is theoretically possible, and I would go as far as to say practically possible, to interoperate between Envoy-based service meshes. Ultimately, at the end of the day, Istio and other projects are just configuring Envoy, and for a period of time, the control planes can go away and the mesh will continue to operate. That's the beauty of distributed systems. So you could interoperate with other Envoy-based things easily, and it's all based on open standards. It's all TL. It's part of the TLS standard, for example. So you can interoperate with things that speak just TLS and that don't run Envoy. You can use mutual TLS in that way. We don't see a huge market demand for people who want to configure things that way. There have been a couple of startup kind of projects. I think there was one from VMware at one point talking about mesh federation, but ultimately we find that people tend to use a single project throughout. People are more than willing. People who are interested would be happy to help again if anyone wants to find ways to interoperate, but that hasn't risen to a roadmap item for us because there's just no demand for it.
That being said, we do have an effort internal to the security working group. It's gone through a number of names. I think the latest is HBone, and I couldn't tell you what that stands for. It's definitely an acronym, But the idea is to take the way that we do MTLS over SPIFFE as Istio and codify that as an HTTP RFC. So that we can depend on other mesh implementations to do MTLS the same way towards an eventual goal. And this is very eventual. I'll like highlight that a lot, of the ability to interoperate on the data plane layer. They wouldn't be sharing any configuration between them, but they would be able to respect and validate one another's identities. I don't expect to see. Yeah.
Sorry, I was going to say it's the HTTP2 based overlay network.
Thank you.
Got you. Very good. This is great. Last question, if I may. And this may, well, this is, is applicable to Istio. Maybe it relates in some respects to Envoy or to other related projects, but support for, or protocol support for HTTP, HTTP2, NATS, gRPC for the variety of protocols that are out there. We had just gotten done reviewing and admitting Iraqi mesh that
I just pulled their webpage up as my example to guessing that may be what your question was, but please continue.
Yeah, and was, I guess the question comes around Istio's, the core project's roadmap toward other protocols.
Yeah,
Right.
so that is dependent on their implementation in Envoy. We've seen people who have, Kafka, I think, was one early one that people were building Envoy filters. Again, members of the Istio community who wanted to be able to proxy. I think Banzai Cloud, who were later acquired by Cisco, built out a lot of that. Iraqi is a project from a bunch of Chinese cloud vendors, if memory serves, that is effectively extension points to Istio to be able to support extra layer 7 protocols. So again, the 80-20 model, which has the Pareto principle or something, it has the benefit to say that it turns out that most people are using HTTP or a variant of it. And if you squint hard enough at gRPC, you can call that a variant of it too. So we're definitely able to use with a very small number of protocols to be able to hit the large majority of things people want. There are obviously things that are running on TCP, MySQL, Redis, for example, that you are able to proxy and make useful within the mesh at layer 4. And adding support for them may or may not make sense in the way that we think about microservices traffic. So we are definitely focusing our attention on the things that are most commonly required. It's great to see people who are building things out there. Mitch, I don't know if you have anything more to.
No, I think you covered it. Like we have, I'm looking, coming up on a dozen protocols directly supported in the Istio project. And our stance for a little bit has been pull requests welcome. If you've got a protocol that you really want Istio to be directly aware of, an Envoy filter is not enough for you to handle that. You actually want first-class support. Work with the network working group and submit a pull request. I think we've had 1 or 2 added within the last 12 months.
Nice. Oh, very good. For others on the call, questions that you all might have for the Istio project. Again, so Istio proposed for incubation level. And sort of while I give people a time to think if they do have questions, Craig, if you'd be so kind, you may have already done this, but a link to today's presentation would be great.
One will come after the recording. I will add, though, a link to the due diligence document.
Anybody else have questions for Craig and Mitch?
Bob, do you have anything? Just to prove we didn't set you up.
Honestly, none for me.
Nice. Yeah, this is great. Mitch, Craig, thanks so much for the presentation today. Enlightening, helpful. We'll get it out to others to rewatch. And congrats on the project thus far. The hopefully the due diligence will we'll try to grease wheels where possible. So
Thanks a lot, Lee.
cool. Yeah.
Thank you.
Thank you all. Bye, guys.
Later.